first thing I want to explain is Drill's unique data model. And so if you think of all the data in the world, you can kind of look at it as these kind of 4 different categories. So on the bottom left here, we have data that is flat and has a fixed schema. So this would be your typical relational table or a CSV or a TSV file, right? You have fixed columns, and then each column just has, or each row has a set of values for those columns. There's no arrays, there's no nested values. On the top left here, you have data that's also has a fixed schema. So the schema is described with the data, but it supports complex structures. So things like arrays and nested values and things like that. At the bottom right, we have HBase as an example, where you have a flat structure, so there's no nesting or no arrays there, but this is schema-free. So what I mean by that is that different records within an HBase table can actually have different fields. And that's very convenient, very flexible when you want to evolve the structure of your data over time. Maybe you're adding some fields to that log structure, or maybe you have very sparse data in or maybe you're encoding different data in the field names. And then on the top right, we have JSON and MongoDB, which, as you know, have become very, very popular formats today because they are very, very flexible and easy to use. And today, every online API and a lot of systems use JSON. And so JSON is both schema-free and supports complex structures. So a single record, or what's called a JSON document, can have nested elements, basically a hierarchy, and it can also have arrays in there. And it's also schema-free. So within a JSON file, you would have many JSON documents, but each of them could have different fields. And similarly to the HBase case, that allows you to then evolve the structure very easily, and it's basically very flexible. You control the structure from the application, as opposed to kind of a centralized schema, the way you would have in a traditional database. So in terms of the data model, the traditional relational data model, which is what every other SQL engine uses, is a great fit for this kind of data, right? So you can very easily use a standard kind of query engine, a SQL query engine, and query this kind of flat, fixed schema data, right? The data that has a fixed schema and doesn't have any arrays or any nesting. But the problem is that a lot of the modern data today is in these types of formats and systems. And in order to query that kind of data with a query engine that has a relational data model or supports the relational data model, you actually have to transform that data into a flat, fixed schema format, into a relational format, right? So you'd have to run an ETL process, or at a minimum restrict some of the data, so then you lose the ability to access a lot of the data. And so when we observed this situation early on, when we were kind of coming up with the idea for Apache Drill, we decided to try to do something that had never been done before, which is to build a SQL query engine with a JSON data model. And when you have a JSON data model, that actually fits all of this data. So you can take any data that you see, any of these types of data, and if the query engine supports a JSON data model, you can actually query that without transforming the data, without restricting it in any way. So an HBase table can be logically represented or thought of as a collection of JSON documents, as can a CSV file, as can an Avro file. And so this is really the most flexible, and it's a superset of all of these different types of formats. And so how do you get this kind of flexibility, though, and not sacrifice performance? That's what a lot of people ask me, right? Is how do you do that? Because it would be easy to do this in a trivial kind of interpreted way and achieve high performance or low performance. And so Drill does 2 things that enable it to run very, very fast with this kind of data model. The first thing is what we call data-driven query compilation and recompilation. And you could think of that as schema discovery on the fly, or schema on the fly. And what Drill is doing is that when it gets the SQL query, it doesn't know in advance what the data is going to look like, especially in the cases of JSON kind of files, MongoDB collections. And so it has to be able to recompile that query on the fly as that query is running. And Drill does that, and actually does that in a very efficient way. So it actually uses multiple different Java compilers underneath the hood, taking advantage of the kind of the unique characteristics of each one. It also does things like bytecode rewriting, dynamic bytecode rewriting, where it changes the actual bytecode of the compiled query to get faster execution. So there's all sorts of techniques that we do based on the data that we're seeing to recompile the query on the fly. That's very different from any other kind of traditional query engine, which actually has to know the schema up front, and it uses that schema to compile the query. And so the compilation of the query has nothing to do with actually the data that's being observed. That's known ahead of time. And Drill, in order to support this data model, of course, can't do that. The second thing is columnar execution. And while there have been columnar systems before, Drill is the first columnar execution engine that actually supports complex and schema-free data. And so you think of all this data, well, it doesn't really have columns, yet Drill is able to do essentially columnar execution. And it does that by shredding these records into pieces in memory. We do what we call shredded in-memory columnar execution. And so we take pieces of these JSON documents, for example, and we store them in kind of a typical columnar way. And that also allows us to then do various types of operations as pointer operations, as opposed to having to actually copy a lot of data and shuffle a lot of data during the query. So this gives us a big performance advantage when we're dealing with these types of data. And so these things these are just two examples of things that Drill does under, in its internals that have never been done before. And that's what enables Drill to combine this kind of flexibility with very, very high performance. And so with that hopefully that gives you a good understanding of the Apache Drill project and what it's about. And what I would encourage you to do is go to the Apache Drill website at drill.apache.org, download Drill onto your laptop. It can run on Windows, Mac, Linux, and go through one of the tutorials on the site and really get your hands dirty. And hopefully you'll like it. Thank you.